Hey Bret, why are you wearing that wig?
Wig? What wig? Just kidding. I got this wig from the dev team at Party On, an online party store. They asked me about how to integrate their microservices asynchronously. I said, we might have something for them in our serverless toolbox.
Sounds great. Stay tuned if you want to know more.
The team at Party On was facing a challenge. They have a public web app and several microservices built on Google Cloud Platform. These apps and services need to communicate with each other. For example, when a customer places a new order.
At first, they tried synchronous HTTPS calls between apps and services. But that is brittle, as it requires apps and services to know a lot about each other. And if a service is temporarily down, messages are lost.
They realized that they needed an asynchronous, event-driven architecture. One service publishes an event without knowing about the other services. The other services get notified about the event asynchronously. If a service is down, the notification is resent when it comes back up.
Cloud PubSub makes it easy to build such an architecture.
When a customer places an order, the back end of the web app publishes an order placed message to Cloud PubSub.
The order and payment services are cloud-run microservices, triggered by PubSub messages sent in a PubSub push subscription. Cloud Run lets you pick your programming language, and it is serverless, so the ops team at Party On can focus on more strategic activities than simply keeping servers patched and running.
The order and payment services subscribe to order placed messages, so they get notified and can take action. For example, the payment service can call the payment processor.
When the payment service learns that the payment was successful, it publishes a payment success message to PubSub. The order service can then create a pick list for the warehouse team.
The team at Party On deployed a bad version of the order microservice once. The service was completely unresponsive. After an hour, they rolled back to the previous version. They were relieved to see that no messages were dropped. Cloud PubSub simply resent them when the order service came back online.
A few weeks later, the team split up the order microservice into two services, order and warehouse. Both services subscribe to payment success messages. The payment microservice, which publishes those messages, did not have to change at all.
Decoupling services like that sounds very useful. The team at Party On gave me this $1 US bill. How many orders would they be able to send over Cloud PubSub for $1?
Let's say each order message is 10 kilobytes, and that each order results in 6 publish and delivery actions. If Party On processes 400,000 orders, they will spend just under $1 on Cloud PubSub.
That's a lot of orders. But Martin, we didn't show any code in this episode, did we?
That's right. Check out the next episode where we will walk through the code for Party On's async processing.